Hey guys, welcome to Intellipaat. As you already know, that data science is ruling the world with its wide variety of application across various industries. Therefore, there is a huge demand for data scientists and companies actively hires data science professionals. Now, while hiring, one of the most important skills that they look into the data science professional is that they should have good R programming skills. Further, knowing the importance of R programming as it is widely used in the field of data science, we have come up with a comprehensive tutorial on R interview questions and answers, where you will get the knowledge and experience about what type of questions are asked from R programming in data science interviews. Now, before moving ahead, do subscribe to Intellipaat's YouTube channel and press the bell icon so that you never miss out an upcoming update from us. Now, let's begin with the session. Now, let us begin with our programming interview questions and answers. So, the first question is, we have to compare R and Python. So, what are the differences in R and Python? So, starting with R programming, it helps in model building and it is similar to Python. And talking about Python programming language, so it is also used for model building similar to R. So, these are the common things or a common objective that is achieved using R as well as Python programming. Then talking about R programming, model interpretability is good. Then in Python programming or using Python programming, model interpretability is not good as in comparison to R programming. Then coming to production, so production is not better than Python in R, and Python provides a better way and more functionalities, packages and libraries for the production of the model. Then R has good community support over Python, and community support in Python is not better than R. There are more professionals and there is a large community of R developers. Then comes in R, the data science libraries are same as Python, and in Python the data science libraries and packages are same as R. That is, they serve the purpose of data analysis, data manipulation, creating machine learning as well as AI models. So, both of these programming languages consist of various libraries and packages that are used in data science. Then R has good data visualizations libraries and tools, whereas data visualization libraries is not better than R in Python programming. So, R provides more informative and beautiful graphs in comparison to Python programming. Then for R, it has a steep learning curve, and in Python the learning curve is easier than R because, as you already know, Python is one of the simplest programming language. So these are the points of comparison between R and Python. Now let me go to the next question. Explain the data import in R language. So R provides import data functionality in R language, and data can be imported in R language in three ways, and these are: you can select the dataset in the dialog box or enter the name of the dataset as required in the terminal. Then data is entered directly using the editor of R command prompt via data as new dataset. So you can write it in the command prompt for importing the data. And finally, data can also be imported from a URL or from plain text file or from any statistical package or from the clipboard also. So you can import the data in R using these three ways. Now let me go to the next question. Explain how to communicate the outputs of data analysis using R language. So to communicate the outputs of data analysis, you have to combine the data, code and analysis results in a single document using nitar package, and then what you can do is you can verify the findings or the results and add it to them, and you can then engage the conversation between the outputs of data analysis, and then you can redo the experiments by inserting new data values and applying it to different problems. So you have to add the new data again and again, then you will implement the same code on the updated data and see the analysis, then you have to verify the analysis or the result you get from the model. So in this way you can communicate the outputs of data analysis using R language. Now let me go to the next question. We'll see the difference between library and require functions in R language. So starting with library function, it gives an error message if the desired package cannot be loaded, whereas in require, the require function is used inside the function and throws a warning message whenever a particular package is not found. Then in library, it loads the packages whether it is already loaded or not, Whereas in require or while using require function, it just checks that it is loaded or loads it if it is not loaded. So when you will go through the documentation of the require function, it clearly states that neither function will reload an already loaded package. Now the third point in library function is it is better to use the library as it gives the error message if the package is not found during the package loading time, whereas require function will just fail without an error if the package is not there. So these are the differences between the library and the require function. Now let me go to the next question. What are the advantages of using R programming? So these are the major advantages of R programming, and they are: it is open source. That means the software or the original code or the source code is made freely available and may be redistributed and modified in future. So it is freely available. This is one of the most important thing. So it does not have any charges for using. Then it supports data wrangling operations. So data wrangling is actually the process of transforming and mapping data from one raw data into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes such as analytics. So we can say that R programming provides us the libraries, packages and features for data analytics. Then it is highly compatible. It is platform independent. That is, we can run the code, or you can say the R codes, in any platform. Finally, it supports machine learning operations. So we can do a lot of things using R programming. So we can perform data manipulation, data visualization, then data exploration, or we can say exploratory data analysis, then creating machine learning models, and it supports a lot of algorithms that we can actually use for building ML based applications. So these are the advantages of R programming. Now let us move on to the next question. What are the disadvantages of R programming? So apart from the advantages of using R programming, there are certain disadvantages, and these are listed over here. So there is a lack of standard GUI. So when you are using Python for data science or machine learning or for AI, we use Jupyter Notebook, and for R we use RStudio. So you can see the difference between both of these. Jupyter Notebook provides a better GUI that is more easy to go through in comparison to RStudio that we use for R programming. Then R programming is not good for big data. So if you are handling large amounts of data, then you should use Python because it is not efficient for big data. Then comes weak origin. It lacks basic security. It has lesser speed than other softwares that we use for data manipulation, visualization or creating machine learning models. Then another disadvantage is spread across various packages. Now these are the major disadvantages. Now let us move on to the next question. What is the use of with and by function in R? With function applies an expression to a data set, and syntax, you can see the syntax over here. With, you have to give the data and the expression that you want to execute. So it is a generic function that evaluates expression in a local environment constructed from data, and the environment has the caller's environment as its parent. So this is very useful for simplifying calls to modeling functions, and if data is already an environment, then it is used with its existing parent. Now coming to by function, it applies a function to each level of a factor. So by function in R applies a function to specified subsets of a data frame, and first the parameter of by function then takes up the data, and second parameter is which by the function is applied, and the third parameter is actually the function. So this is the syntax of by function. So here are three arguments: data, factor list and function. Now let us move on to the next question. In R programming, how missing values are represented? In R, missing values are represented by NA, which should be in capital letters. So NA is not actually a string or a numeric value, but an indicator of missingness. So we can create vectors with missing values. So x1 and x2 are the vectors, and C function is the combined function. So here are the values in the vector, including 1, 4, 3, NA and 7. And in the vector x2, there is A, capital B, NA and NA as string also. So the values which are in inverted comma, so these are strings, and the original NA value is simply written as NA. So there are also the values that are divided by 0 or are represented by the symbol NaN, which represents that it is not a number. So these values are actually the impossible values that are available in the data set. So there are various methods for handling the missing values that we'll discuss later. So here we have discussed about the missing values, how they are represented in R. Just a quick info guys, if you are interested in learning R programming, then Intellipaat provides an end-to-end R programming course that can help you acquire the right set of skills. So to check the details of the course, you can check out the link given in the description below. Now let's continue with the session. Now let us move on to the next question. What is the use of subset and sample function in R? So subset function in R returns subset of data frame, vectors or matrices which meet the specific conditions. And this is the syntax of the subset function, which includes X, condition and select, where X can be a matrix, data frame or vector. Then condition is the condition that which you want to impose, the condition that you want to use. So that is denoted by the condition. Then comes select, which denotes the column that are to be selected. Now let us look at an example. So here new data is equal to 30. So there is a data set where there are 30 values. We use the subset function and give the arguments. So the above code select the data from the empty cars table where mpg is greater than or equal to 30, and so the output will be, as you can see, that the values of mpg, cy, l and gear. Now let us look on to the next one, that is sample function. So sample function in R generates a sample of the specified size from the data set or elements, either with or without replacement. So this is the syntax of the sample function, that is the sample keyword, and the arguments are X, size, replace and the prob. So X denotes the data set or a vector of one or more elements from which sample is to be chosen. Then comes size, which denotes the size of a sample. After that replace, so there you need to mention should sampling be with replacement. So you need to give it as true or false. Then comes prob, so it gives the probability weights for obtaining the elements of the vector being sampled. So you can see the example using the sample function. We give the values as 1:20, 10 and replace equal to 2. So when we run the above code, we'll get the output as you can see it on your screen, that is 6, 8, 12, then 19, 5, 18, 19, 14, 13 and 2. So these are the 10 values between 1 to 20, and these are actually the random values. So now let us move on to the next question, that is explain what is transpose. So transpose is used for reshaping of the data which is used for analysis. So rotating or transposing our objects frame so that the rows become the columns and the columns becomes the rows. So that is what we are transposing, and we are actually transposing the rows and the columns. So you can see the example image over here. So the original matrix consists of A, B, C, D, E, F, G, H, I, where A, B, C are in the horizontal frame. After applying the transpose on this matrix, the A, B, C comes in the vertical frame, and same is the case with D, E, F and G, H, I. So this is actually the transpose of a matrix. So we apply transpose in a matrix in our programming so that we can analyze the data in different ways. Now let us move on to the next question. Now the question is, why do we use R programming? So R programming is used for data manipulation, data visualization and for creating machine learning models as well as AI based applications. Now starting with data manipulation, as you already know, the data collection process done by machine involves a lot of errors and inaccuracies in reading. So data manipulation helps us to remove these inaccuracies and make the data more accurate and precise. So data manipulation involves modifying the data to make it easier to read and to be more organized. So we manipulate the data for analysis and visualization tasks, and it is also used with the term data exploration, which involves organizing data using available set of variables. So there are many methods and functions in R that we use for data manipulation, such as filter that helps to pick up rows based on their values, then distinct to remove the duplicate rows and to arrange to reorder the rows, then select function that select columns by their names, then rename function is used to rename the columns, mutate function and transmutate function is used to add or create new variables.
So by using all these functions, we can manipulate the data, we can remove the duplicacy, we can arrange them in an order that we can easily understand. So in simple words, we can say that data manipulation is a crucial function for any business operations and optimization. And to properly use data and transform it into useful insights, like analyzing financial data if you are working for any financial organization such as bank or any other company which is related to finance, then customer behavior and performing trend analysis. So here you have to be able to work with the data in the way you need it. So that is why data manipulation is a very necessary task. So using R programming, we can easily manipulate the data according to our use. Then comes data visualization. So whatever data is collected, manipulated and performed exploratory data analysis on it. So we need to analyze and we need to understand the data in the form of graphs and plots so that we can understand the trend, we can analyze it, we can understand it using certain statistical parameters, we can understand the change in the values and the behavior of the customer as well using data visualization. So data visualization is another important part of business analytics task, or you can say data analysis, or it is used in data science as well. So most of the companies uses data visualization to analyze their business, to analyze their customer, the trends of the market, the behavior of the customer, their buying behavior, their interest. So it helps them to make a proper strategy based on the past data visualized and then optimize their business process for gaining or for increasing their revenues. So R programming provides a lot of libraries and packages and tools that help us to visualize the data in a very efficient way with informative graphs and plots. Then comes machine learning. So we can create various algorithms, we can create various models of machine learning using R programming. So there are various functions, various libraries that are present in R for creating classification, regression, clustering algorithms that are used in machine learning. Also, artificial intelligence is one of the field that is covered by R programming. So we can create image classification model as well as CNN, that is convolutional neural network, as well using R programming in artificial intelligence. So we start with data manipulation, then we visualize the data. According to it, we create machine learning models and we can also create AI based applications using R programming. So this is the use of R programming. Now let us move on to the next question. What is the function used for adding data sets in R? So for adding two data sets, we use rbind function where the condition is the column of the two data sets must be same. And here is the syntax of rbind function. We have to write the rbind keyword and then we have to give the argument as x1, x2, where x1 and x2 can be vector, matrix or data frames. So rbind basically stands for row bind. We also use cbind that stands for column bind, that helps to bind the columns, and here the data or the arguments can be vectors, matrices or data frame. And the condition over here for using rbind function is also that it combines vector, matrix and data frame by rows. So the column numbers of the two data sets must be the same, otherwise the combination will not be effective and it will be meaningless. So if two vectors do not have the same length, so the elements of the short one will be repeated. So that is why the number of the column of the two data sets must be same. So this is about the rbind function. And now let us move on to the next question, which is how you can produce correlations and covariances. So correlations is produced by COR function and the covariances is produced by COV function. So correlation, or represented by R, measures a linear dependency between two variables x and y, and it is also known as a parametric correlation test because it depends to the distribution of the data. So here you can see the graph where the correlation is represented. Now coming to covariance, it is a statistical term used to measure the direction of the linear relationship between the data vectors. So here you can see the graph plotted between x and y. So here is positive covariance and the negative covariance. So here you can see the graph for positive covariance and the negative covariance where the data points are spreaded. So in actual words, variance refers to the spread of a data set around its mean value, while a covariance refers to the measure of the directional relationship between the two random variables.
Just a quick info guys, if you are interested in learning R programming, then Intellipaat provides an end-to-end R programming course that can help you acquire the right set of skills. So to check the details of the course, you can check out the link given in the description below. Now let's continue with the session.
And talking more about covariance, it is actually the measure of the joint variability of the two random variables. And here the sign of covariance therefore shows the tendency in the linear relationship between the variables. So in positive covariance, you can see the values or the mean values of the data set are increasing positively, while in negative covariance, they are decreasing gradually. So this is about the correlation and the covariances. And now we'll move on to the next question. What is the difference between matrix and data frame? So data frame can contain different types of data. So as you can see in the table that there are X and Y columns in this data frame, and X consists of the values 12.3 and 3, 5.01, 2.3, and Y consists of mango, orange, banana and grapes. So it can contain multiple data types in multiple columns called fields. So these are called fields. Then coming to matrix, matrix can contain only similar type of data and it has a fixed number of rows and columns. So here you can see the values 12.3, then 3, 5.01, 2.3, and in the next column it has 8.1, 5.2, 3.0 and 0.1. So it can only contain the similar type of data. It cannot have different types of data such as in data frame. Now let us move on to the next question. What is the difference between lapply and sapply? So starting with lapply, so this function is useful for performing operation on list objects and returns a list object of same length of original set. So L in this lapply function stands for list. So we are applying the function on a list. Then coming to sapply, this function takes list, vector or data frame as input and gives the output in vector or matrix form. Then lapply returns a list of similar length as you already know and as input list object, and each element of which is the result of applying fun to the corresponding element of the list. Whereas sapply, it is useful for operations on list objects and returns a list object of the same length of original data set. So in sapply, it is useful for operations on list objects and returns a vector of same length of original set. Now in lapply, it takes a list, vector or data frame as input and gives the output in list itself. But in sapply, it does the same job as lapply, but it returns a vector. So this is the major difference between lapply and sapply function. Now let us move on to the next question. How many data structure R has? So there are 5 types of data structures in R that are shown below in the diagram. So it has vectors, data frame, list, matrix and array. So starting with vector, it is one of the basic data structures in R programming and it is homogeneous in nature, which means that it only contains elements of the same data type, and data types can be numeric, integer, character, complex or logical. So vector in R programming is created using the C function, and coercion takes place in a vector from lower to top, and if the elements passed are of different data types from logical to integer or to double to character, so we use that. Then if we want to check the data type of the vector, we can use type of, and for checking the class of a vector we can use the class function. Now elements of a vector can be accessed by using the indexes that it has inside the brackets to specify the indexes of the elements that are to be accessed, and we can also use logical indexing, negative indexing. Apart from that, we can perform addition, subtraction, multiplication and division on vectors having the same number of elements. Now apart from that, if arithmetic operations are performed on the vectors having unequal lengths, so we can recycle it, and then the vectors elements which are shorter in number as compared to the other vectors are recycled. For example, if we are having a vector 1 containing the value 876501 and we have vector 2 that has 7 and 15, so vector 2 will take the values repetitively of 7, 15, 7, 15 and 7, 15, and when we add the vector, then the corresponding values will be added. So this is how a vector can be recycled. Now we'll go to list. So a list in R programming is a non-homogeneous data structure, which implies that it can contain elements of different data types, and it accepts numbers, characters, lists, and even matrices and functions inside it. So it is created using the list function. Also, the elements of a list can be accessed by using the indices of those elements that are present in that, and we can add and delete the elements only at the end of a list. So this is about the list. Now we'll go to matrix data structure. So the matrix in R programming is a two-dimensional data structure that is homogeneous in nature, which means that it only accepts elements of the same data type, and coercion takes place if the elements of different data types are passed, and it is created using the matrix function. And the basic syntax to create a matrix is you have to give the matrix keyword, and then in brackets you give the arguments as data number of rows represented by n row, then n column for number of columns, then by row, and the dimensions name. So in data you have to put the input element of a matrix given as a vector, and in number of rows you have to give the number of rows that have to be created, then number of columns, the number of columns that you need to create, then by row function, so the row wise arrangement of the elements instead of column wise, and for that you have to use by row function, and dimension name, so you have to give the names of the columns and rows to be created. So this is the matrix data structure. Now after that, coming to data frame. So data frame in R programming is a two-dimensional array like structure that also resembles a table, in which each column contains values of one variable and each row contains one set of values from each column. So the column names of a data frame should not be empty, then row names should be unique, and data stored in a data frame can be numeric, factor, or character type, and each column should contain the same number of data items. So this is about the data frame data structure in R. Now coming to arrays in R. So they are the R data objects which can store data in more than two dimensions. For example, if we create an array of dimension 2, 3, 4, then it creates 4 rectangular matrices, each with 2 rows and 3 columns. So an array can store only similar type of data, and an array is created using array function, and it takes vectors as input and uses the values in the dim parameter to create an array which represents the dimension of it. So this is about the data structures in R. Now let us move on to the next question. What are R packages? So packages are the collection of data, R functions, and compiled code in a well-defined format, and these packages are stored in a library. So as you already know, R is a programming language, and it is free software environment for statistical computing and graphics supported. So they are the essential tools for various data analysis as well as data science, machine learning implementation. So R language is widely used among statisticians and data miners for developing statistical software as well as implement data analysis technique, and implements various data manipulation, data visualization on various types of business data. So this is possible due to the packages that are provided by R. So these packages are actually the development package that help us to visualize the data, manipulate the data, and work on machine learning models as well as create AI based applications. So the package over here refers to the development package that is provided by R. Now let us move on to the next question. What is the function which is used for merging of data frames horizontally in R? So there is merge function that is used to merge two data frames. So here is an example. You can see the sum, which is an instance variable, or you can say the object, which will store the output of the merge function, where the arguments are data frame 1, data frame 2, and the argument for adding, so by equal to id. So it will add the data frames by their id. So it is a unique variable that are present in both the columns. So this is how we merge the two data frames horizontally in R. Now let us move on to the next question. What is the power analysis? So it is used for experimental design that is used to determine the effect of given sample size. So you can see the graph over here. So it is actually an important aspect of experimental design which is used to detect an effect of a given size with a degree of confidence. So there are various steps for calculating the sample size for doing power analysis. So you can specify a hypothesis test, specify the significance level of the test, then you can specify the smallest effect size that is of scientific interest, and then you can estimate the value of other parameters necessary to compute the power function. So also you have to specify the intended power of the test, and then you have to calculate it. So determining a good sample size for a study is always an important issue. So power analysis combines statistical analysis and subject area knowledge and the requirements to help you derive the optimal sample size for your research or study.
Just a quick info guys, if you are interested in learning R programming, then Intellipaat provides an end-to-end R programming course that can help you acquire the right set of skills. So to check the details of the course, you can check out the link given in the description below. Now let's continue with the session.
So there is also a good power analysis value, and the desired power level is typically 0.8, but the researcher performing power analysis can specify the higher level such as 0.9 also, which means that there is a 90% probability that the researcher will not commit a type 2 error. And one of the stringent factors in power analysis is the desired level of significance that we use for our data. What is the use of abline function? So abline function adds the reference line to a graph, and the R function abline can be used to add vertical, horizontal or regression lines to a graph. Also here x and y values are single values specifying the intercept and the slope of the line. So here is the syntax for abline function. So we have to use abline keyword, then in brackets we have to give the y values and the x values represented or stored in h and v. So these are specifying the intercept and the slope of the line. So this is the use of the abline function. Now let us move on to the next question. What is iplots? So it is a package which provide bar plots, mosaic plots, box plots, parallel plots, scatter plots and histogram. So iplots is actually a package for the R statistical environment which provides high interaction statistical graphs that are written in Java, and it offers a wide variety of plots that you can see over here, that is histograms, bar charts, scatter plots, box plots and many others. So by using iplots in R, we can actually visualize our data in a much efficient way. So besides these interactive plots, iplots also provide an API for managing plots and adding user defined objects such as lines or polygons to a plot. And the version 2.0 of it not only adds new multivariate plots and interactive features throughout all the plots, but also lays the foundation for interactive and customizable plots. Now this is about the iplots. Now let us move on to the next question. What is the use of corrgram function? So corrgram function is used to plot correlograms. So the cells of the matrix over here can be shaded or colored to show the correlation values. So in the analysis of the data, a correlogram is a chart of correlation statistics. For example, in time series analysis, a plot of the sample autocorrelations versus the time lags is an autocorrelogram. So if cross correlation is plotted, then the result is called cross correlogram. So this is the use of the correlogram. Further, the correlogram is a commonly used tool for checking randomness in a dataset. And if non-random, then one or more of the autocorrelations will be significantly non-zero. So in addition, correlograms are used in the model identification stage for auto-regressive moving average time series models. Now this is all about the corrgram function. Now let us move on to the next question. How to create scatterplot matrices? So we use pair or splong function for creating scatterplot matrices. So this is useful to visualize correlation of small data sets, and each scatterplot in the matrix visualizes the relationship between a pair of variables, allowing many relationships to be explored in one chart. Then scatter plots used to visualize bivariate relationships between combination of the variable, that is same as visualization between different types of variables in a same plot. So the scatter plot matrix shows all the pairwise scatter plots of the variables on a single view with multiple scatter plots in a matrix format, and this gives us a more sorted way of representing the data and understanding the relation between the variables as well as visualizing it for further analysis. So here you can see a scatterplot matrix is a grid or matrix of scatterplots that is used to visualize the data and the relationship, and the scatterplot matrix is composed of a grid of mini plots. So there are multiple plots over here and one larger preview plot that shows a selected mini plot in more detail. So there are variables you can see over here that shows sepal length, sepal width, petal length and petal width. Now this is about the scatter plot matrices. Now let us move on to the next question. What is the use of a diagnostic plot? So it is used to check the normality, heteroscedasticity and influential observations. So diagnostic plots actually show residuals in 4 different ways. Residuals versus fitted and used to check the linear relationship assumptions. A horizontal line without distinct patterns is an indication for a linear relationship that implies what is good or what is not good. Then there could be a non-linear relationship between the predictor variable and an outcome variable, and the pattern could show up in this plot if the model doesn't capture the non-linear relationship. And if you find equally spread residuals around a horizontal line without distinct patterns, that is a good indication you don't have a non-linear relationship. Now coming to normal QQ. So this plot shows if residuals are normally distributed. So it also answers the question, do residuals follow a straight line well or do they deviate severely? Then it's good if residuals are lined well on the straight dashed lines. Then coming to scale location, it's also called spread location plot. So this plot shows if residuals are spread equally along the ranges of predictors, and this is how you can check the assumption of equal variance, and it's good if you see a horizontal line with equally or randomly separated points. Now residuals versus leverage. So in this, plots help us to find influential cases, that is subjects if any present in it. So not all the outliers are influential in linear regression analysis, but even though data have extreme values, they might not be influential to determine a regression line. So that means the results wouldn't be much different if we either include or exclude them from analysis. So they follow the trend in the majority of cases and they don't really matter, they are not influential. On the other hand, some cases could be different or influential even if they look to be within a reasonable range of values. So there could be extreme cases against a regression line and can alter the results if we exclude them from analysis. And another way to put it is that they don't get along with the trend in the majority of the cases. Now this is about the use of the diagnostic plots. Now let us move on to the next question, which is define ANOVA function. So ANOVA is used to compare the nested models. So it stands for analysis of variance and is an analysis tool used in statistics that splits an observed aggregate variability found inside a dataset into 2 parts, that is systematic factors and random factors. So the systematic factors have a statistical influence on the given datasets, while the random factors do not. Moreover, ANOVA is a statistical test for estimating how a quantitative dependent variable changes according to the levels of one or more categorical independent variables. And ANOVA tests whether there is a difference in means of the groups at each level of the independent variable. So this is about the ANOVA function and its usage. Now let us move on to the next question. What is the use of MANOVA? So MANOVA stands for multivariate analysis of variance. And by using MANOVA, we can test more than one dependent variable simultaneously. So the multivariate analysis of variance or MANOVA is an ANOVA with 2 or more continuous outcomes or response variables. And the one way MANOVA tests simultaneously statistical differences for multiple response variables by one grouping variable. So what is the use of MANOVA, or what is MANOVA used for? So this multivariate analysis of variance is a type of multivariate analysis used to analyze data that involve more than one dependent variable at a time, and MANOVA allows us to test hypotheses regarding the effect of one or more independent variables on 2 or more dependent variables. So the actual difference between ANOVA and MANOVA method is ANOVA method includes only one dependent variable, while the MANOVA method includes multiple dependent variables. So MANOVA is actually used to determine whether there are any differences between independent groups on more than one continuous dependent variable, And in this regard, it differs from one-way Anova, which only measures one dependent variable. Now, this is all about MANOVA. Now, let us move on to the next question. What is logistic regression? So, logistic regression is used to predict the binary outcome from the given set of continuous predictor variables. So, logistic regression is actually a supervised learning classification algorithm used to predict the probability of a target variable. And the nature of target or dependent variable is dichotomous, which means that there would be only two possible classes. So, here 0 or 1. 0 represents that it is incorrectly classified output and 1 represents the correctness of the output. So, there are types of logistic regression. So, here logistic regression is the proper regression analysis, as you already know, that is used when the dependent variable is categorical or binary. So, there are three types over here: binary logistic regression, multinomial logistic regression and ordinal logistic regression. So, in binary logistic regression, only two outcomes are possible, whereas in multinomial logistic regression, there are more unordered categories. And in ordinal logistic regression, there are three or more ordered categories. Now, this is about logistic regression. Now, let us move on to the next question. Define Poisson regression. So, it is used to predict the outcome variable which represents counts from the given set of continuous predictor variable. So, Poisson regression actually assumes the response variable y has a Poisson distribution and assumes the logarithm of its expected value that can be modeled by a linear combination of unknown parameters. So, a Poisson regression model is sometimes known as a log linear model, especially when used to model contingency tables. So, why do we actually use Poisson regression? So, it is used to predict a dependent variable that consists of count data given one or more independent variables. And the variable we want to predict is called the dependent variable, or sometimes the response or the outcome, or you can say the target variable. So, that is why we use Poisson regression. Now, let us move on to the next question. Define cluster.stats function. So, it is defined in the FPC package, which provides a method for comparing the similarity of two clusters solution using different validation criteria. So, clustering in R is actually a technique of data segmentation that partitions the data into several groups based on their similarity. And basically, we group the data through a statistical operation, and these smaller groups that are formed from the bigger data are known as clusters. So, talking about cluster stats, it computes a number of distance based statistics which can be used for cluster validation, comparison between clusterings and decision about the number of clusters. So, it can be cluster sizes, cluster diameters, average distances within and between the clusters, then cluster separation. It can be biggest within cluster gap and average widths. So, here you can see it in the plot. There are three clusters represented by different colors, and we can calculate the cluster diameters, cluster sizes as well as the distance between the clusters using the cluster.stats function. So, this is about cluster.stats and why do we use it. Now, let us move on to the last question of this R programming interview questions and answers tutorial. What is principal function? It is defined in psych package, which is used to rotate and extract the principal components. So, basically it is just doing a principal component analysis for n principal components of either a correlation or covariance matrix, as you can see in the graph. Also, this returns a subset of just the best n factors. So, it can show the residual correlations as well, and the quality of reduction in the squared correlations is reported by comparing the residual correlations that we evaluated or calculated to the original correlations. So, here are the two plots. So, first one is transformed non-standardized training datasets after PCA and transformed standardized training dataset after PCA. So, you can see the difference after the rotation and using the principal function that is applied for the principal component analysis, and it changes the component as you can see in the plot over here, and it helps to represent the classes differently, and we can make a cluster of it to analyze it in a better way. So, this is about the principal function.
Just a quick info guys, if you are interested in learning R programming, then Intellipaat provides an end-to-end R programming course that can help you acquire the right set of skills. So, to check the details of the course, you can check out the link given in the description below. This is the end of this video. If this video was informative to you, then like and share it. Also, if you have any doubt or queries, then you can post it in the comment section. Finally, do subscribe to Intellipaat's YouTube channel and press the bell icon so that you never miss out on our upcoming updates. Thank you.